So lesson 5.3 is homework. 1 through 25, we're skipping 7 and 21. So we're covering rates. And question number 1, they're going to give you this paragraph and they're going to ask you to identify all of the rates or name all of the rates. And so really what the reason they're asking you this is just to make sure you understand what a rate actually is. You should be able to find it. So there's a whole bunch of rates that we're going to find here. So it says the Indianapolis 500 is one of the most famous auto races in the United States with hundreds of thousands of people attending annually. So that would be a rate right there. So hundreds of thousands of people. Now that alone is not a rate, but it's how many per year. That word per kind of gives away a rate. Very often, these rates are with time. Okay, so it's hundreds of thousands of people per year or per hour or per minute, things like that. Those are all rates. So it says attendees in 2006 paid from $40 to $150 per ticket. Both of those are rates. So $40 per ticket or $150 per ticket. Plus 20 to 50 per hour to park. So we got more per hours here. So $20 per hour and $50 per hour. They reach speeds of more than 230 miles per hour. Miles per hour, which is equivalent to 354 kilometers per hour. These are all rates. And that was all as they raced around the 2.5 mile oval track. So you may not have caught that last one that you could interpret as a rate, but it's 2.5 miles per lap around the track. So those are all just different examples of what a rate is. And then question number 2, give an example of a rate with some other kind of unit that's not mentioned. And so in the answer key, they said John is typing at a speed of 30 words per minute. And you could say, it could be any example. So let's say how many texts you're sending per day, anything like that. Just coming up with a separate rate. All right, number 3. 3 through 5, we're going to calculate a rate by the given information. So Danielle walked her dog 6 blocks in blank minutes. And so what this rate will give you is how many blocks per minute. So let's just pretend it was 6 minutes. If you did 6 blocks in 6 minutes, that's 1 block per minute. Or let's say it was 3 minutes. 6 blocks in 3 minutes. That means it's going 2 blocks per minute. So what you're actually doing, so if you had the 6 divided by 6, that's 1 block per minute. Or 6 divided by 2, 6 blocks in 2 minutes, that's going to equal 3 blocks per minute. Minute number 1, you walked 3. Minute number 2, you walked another 3 for a total of 6. So what you're doing is you're taking your number of blocks and you're dividing it by the minutes. So the answer here is 6 over t. Number 4. So we've got 7 days, and they're going to tell you how many hours he slept for all of those nights, and we're going to come up with a rate out of that. So we're going to be dividing by 7, and we're basically just finding an average. So how much he slept per night. So we got to add up all these different ones. So he slept for 6.5 hours one night, so 6.5. Then 7 hours for 2 nights. So you do need to count each one as an individual night. 7.5 for 2 nights. 8 hours one night and 9.5 one night. So all of that is going to get added up and divided by 7. And it comes out to approximately 7.57 hours per night. All right, number 5. In 2004, 2.3 billion books were sold. Population was 296 million. So we are going to set up our rate for how many books per person. Now you can always read a rate from top to bottom. So as you divide it, it's books per person, if that's what you want. Or if you want people per book, then you'd have to flip-flop your numbers. So we're going to go books per person. So we're going to put the number of books up top. Now the trick here is, how do I deal with 2.3 billion? And so think of what 2 billion would look like. 2 comma and all the zeros. When it's 2.3 billion, you just put the 3 in the next place value spot. So right now, this is 2,300,000. This is 2.3 million. So we need 3 more zeros here for our billion. So it's actually 2,300,000,000. It's the same as 2.3 billion. And that's for 296 million. I'm going to divide those up. Obviously, you just plug that in the calculator. It comes out to about 7.77 books per person. Number 6, playing a video game 4 different times. We are not going to find out the actual amount of points. They're going to be represented for each of the 4 times by a variable. We're going to give an expression for her average score. So if we knew her score all 4 times, we wanted the average, you'd add them up and divide by 4. So we're just expressing that with a variable. So for part A, give an expression for her average score. It's her points all added up, divided by 4. And her average is a rate. So what's the rate unit? And again, you're going to read it from top to bottom. These represent all her points per, and then the bottom is the number of games. So it's whatever you read it from top to bottom. These represent points. This represents games, so it's points per game. Oh, and we didn't have to do number 7, so going to number 8. Multiple choice, which one of these is not equal to the others? So as we look through it, we're really just dealing with some negatives here. And we've talked about how with division or setting up a fraction, the negative sign can go up top, it can go out front, it can go in the bottom. But as long as it just shows up once, then that's a negative. If there's 2 negatives, though, one in the top, one in the bottom, they will cancel each other out and create a positive. And so this is actually going to become a positive, which will be different than these 3. And then letter E, it's a negative, negative. So up top, a negative, negative will become a positive. Then we do have, once they go away, and that's positive, now you have that 1 negative in the bottom. So it's very similar to what you see on letter C, is what it would look like. So this would be a negative, as would A and B and D. Those are all going to end up negative answers. C is going to be a positive. So for letter 8, the answer is C. All right, for 9 through 11, we have an A and a B for each one. So for letter A, for what values of the variable is the expression equal to 0? And then for letter B, for what values is it undefined? So when we're dealing with these fractions, it's undefined when we have a 0 in the denominator, because you can't divide by 0. But if you get a 0 in the numerator, 0 divided by anything is just 0. So for part A, when they say when is the expression equal to 0, it's when we end up with a 0 in the numerator. And part B, when is the expression undefined? That's when we end up with a 0 in the denominator. Okay, so for part A in number 9, for this to be equal to 0, we'd have to get a 0 up top. So what would we plug in for W to get a 0? It'd have to be a 12, because 12 minus 12 is 0. And then if we wanted this to be undefined, we'd have to create a 0 down here. So something plus 5 has to give me 0. That would be negative 5. So number 10, how do we create a 0 here? By plugging in for M. There's nothing we can plug in for m that's going to make a 0 here. We can get a 0 at the bottom, and that's going to be undefined. But to make the entire expression 0, we have to affect the numerator, not the denominator. And we have no way to do that. Okay, so there is no possible answer here, or the answer key just says none. Part B, if it's going to be undefined, that means a 0 is in the denominator. It cannot divide by 0. So how do we get that? This m would have to be a 4. So 4 minus 4 is 0. And then for 11, part A, to create a 0, we need a 0 in the numerator. So 2 plus what gives me 0? That would be negative 2. In part B, is there any number we can plug in for a y to make this undefined? Nope, because to make this undefined, I need to affect the denominator. Y is not going to affect the denominator. The denominator is always 15. So this will never be undefined. And so for what value of the variable is it undefined? There is none. There's no value that we can plug in. Okay, number 12. When you buy something in quantity, the cost of one item is the unit cost. So how much does it cost for one? Find the unit cost for each. So it's the dollars per item. So when we set these up, the order that you divide is important. So like we talked about earlier with the rate, you read it from top to bottom. So we want the price per whatever. So here we have frozen juice, 3 cans for $5. We want to know how much does it cost for 1 can. So we need the cost per can. When you set this up, it's really important that you put the numbers in the right order. So it's $5 for 3 cans. We're going to go ahead and divide that. Now, we're talking about money, so we don't want to leave this a fraction. 5 divided by 3 is not going to be a pretty decimal, and we normally just leave those things then as fractions. But since this is talking about money, we're not going to leave it as a fraction. That's just not what we normally deal with. So it's going to be $1.67. We'll round it, and that's per can. All right, that was part A. Part B, 500 sheets of paper for $2.49. Again, we're going to put the price per sheet. So it's $2.49 for 500 sheets. We're going to go ahead and divide that out. And we're going to take a look at this. I'm going to go write the whole thing out. Now, here's your dollars and your cents. So it's not even a full cent. If you were rounding, you'd actually round this to 0. But clearly, if you're spending $2.49 on 500 sheets, you're not spending 0 per sheet. So as we go out to here, this is actually half of a cent. Because if you took this twice, we'd pretty much be up to 1 cent. So if you rounded this to 0.005, because the 9/8 knocks it up to a 5 if you're rounding it, and you took this twice, so if you added it to itself, that would get you 1 cent. And so this is actually half of a cent per page. So a little bit weird to deal with a number so small, but when you're buying things that cost so little for just one individual, where you normally buy in bulk, things can cost less than a penny. But obviously in the store, you're never going to buy one. You couldn't pay for 1 sheet of paper, but you can buy the pack of 500. But when you're comparing these prices, there could be another pack of 750 for a price close to $2.49. And if you wanted to know which one was the better deal, you'd have to find the unit cost. So we're going to go all the way down to how much does 1 piece cost. All right, and then X paper clips for 69 cents. Again, we want the price per paper clip. So it's 69 cents price per paper clip, and X is going to go on the bottom. So that's the price per paper clip. All right, so just using a variable in there to represent some things. 13. We're going to complete this table. So let's write down all the ones that we're going to do. And so using this, y equals 1 plus x over 2 minus x, we're going to complete the table at the right. So I'll do 1 or 2 and show the work, and then we'll just go ahead and talk about it in our heads. So y equals, we're going to plug in -3 to start with. So 1 plus -3 over 2 minus -3. Translate that out. 1 plus -3 is -2. 2 minus -3 goes plus plus, and that's 5. So it's -2/5. For -2, it's 1 plus -2 over 2 minus -2. So 1 plus -2 is -1. 2 minus -2 goes plus plus, and it's 4. So -1/4. All right, now we're going to start seeing some things that go back to our undefined and zeros. So we need to make sure we know if we get a 0 on the top, that means our answer is 0. If we get a 0 on the bottom, it's undefined. So we got to be able to recognize those differences quickly. So it's 1 plus -1 over 2 minus -1. So we're going to get a 0 on the top. And it really doesn't matter what we get here on the bottom. We just need to make sure it's not another 0, because that would be undefined. So 2 minus -1 goes plus plus, that's 3. 0 divided by 3 is 0. Very often, students just automatically say, oh, well, 0 is going to be 0, right? Well, nope, because we're plugging it in for x. So it's 1 plus 0 over 2 minus 0. So it's just going to be 1 over 2. So when you plug in 0 for x, you get 1/2 for y. And then let's kind of talk through the rest here. So I'm just going to write it out with the x, and we'll just mentally plug it in. So we're going to plug in a 1. So it's going to be 1 plus 1, so 1, and 2 minus 1. I'm sorry. I knew something was off. Yeah, 1 plus 1 is not 1. 1 plus 1 is 2, and then 2 minus 1 would be 1. So I got 2 over 1. So that's 2. Now if I plugged in 2, 1 plus 2 is going to be 3. 2 minus 2 is going to be 0. So we get a 0 on the bottom. We can't divide by 0. So this is undefined. Obviously, a big mistake students make there is they put 0. And then 3, 1 plus 3 is 4 up top. And then at the bottom, 2 minus 3 is -1. So you get 4 over -1, which is just -4. So there's our table on 13. Okay, 14. Very fast runner can run a half mile, so 1/2 of a mile, in 2 minutes. We're going to express the average rate in these units. So this already is a rate. Now we're going to do miles per minute. Miles per minute. So we're going to have to divide 1/2 miles by 2 minutes, and that will give you the miles per minute. So it's 1/2, or 0.5, divided by 2. So it's 0.25, or which we should know is 1/4 miles per minute. And just think about why that should make sense, even if we didn't understand the dividing and any of that stuff. If you run a half a mile in 2 minutes, 1 minute is going to be just half of this. So what's half of a half is a quarter. So that makes sense. Letter B, we want minutes per mile. So we're going back here, and now we're going to put minutes on top and miles on the bottom. So minutes per mile. So 2 divided by 0.5 is 4. For what? Rated from the top to bottom, minutes per mile. Let's think about why that makes sense. If you run a half a mile in 2 minutes, we're going to know how many minutes per mile, how many minutes for 1 mile. So you did half a mile in 2 minutes, so 1 mile is going to be in 4 minutes. So 4 minutes per mile makes sense. So this is one that's simple enough, and it's something we can relate to enough that you might be able to just reason through it in your mind. But we're going to have plenty of situations where we have to come up with a rate where it might not be so obvious. And so we always have to fall back to writing it out from top to bottom in the order that we want this to produce. So you want miles per minute, you set it up that way. You want minutes per mile, you set it up that way. And notice these two numbers that they've given you, they're reciprocals of each other because you flipped these fractions. But they are going to give you a different number, so the order does matter. Letter C, we want miles per hour. Miles per hour. So there's a couple different ways you could go about this one. You could go ahead and figure out 2 minutes, what fraction that is of an hour. So 2 minutes is out of 60. So you could take 2 out of 60, that's the fraction. Okay, and you could do miles per hour. This is how many hours. So you could do 1/2 miles divided by this many hours and go about it like that. That'll get you the right answer. But we can also take this number right here. This is how many miles per minute. So we want a quarter mile in 1 minute. So if we want to make that into an hour, every minute you run a quarter mile. So there's going to be 60 minutes. So you can do 60 times 1/4, which is basically just dividing by 4 because you're going to get 60 on top and 4 on the bottom. And so that's 15, and that's miles per hour. Going back to this one, let's say you set it up like this. Your miles per hour, you understood that this is a fraction. 2 minutes is the fraction of an hour. Going back to what we did in the last section, you would take this division problem and turn it to multiplication, and you would flip this, and you'd end up like this. And you can see when you multiply that across, you're going to get 60 over 4, and it would get us right back there. So that you can see how this is related to the work we were just doing in the last section. Okay, 15. So for each state below, find the number of people per square mile. So people per mile, that's the order we're going to set this up. To the nearest tenth, this is the state's population density. So when you find the number of people per mile, that's known as a population density. So for New Jersey, we had 8.7 million people. So we have to remember how we write that out. So think about 8 million, all your zeros. If it's 8.7 million, you just put 7 in the next spot. So it's actually 8,700,000 divided by 8,700. So again, this is people per mile when you actually go ahead and divide it. And that comes out to 1,000 when you divide that. People per mile. Square mile, so we're going to go like this, miles squared. That's letter A and letter B. 0.9 million. So a 0 basically goes in the million spot, which we don't even need to put there. That wouldn't make sense. And the 9 is going to go right here. So it's actually 900,000 because it's 0.9 million. It'd be 0,9. So it's actually 900,000 divided by 147,000. And so let's do that. And it said to the nearest tenth, and so we're going to round that to 6.1. So it's approximately, put a little squiggle for approximately, 6.1 people per square mile. (16). This one's a little tricky. It says in T minutes, a copy machine made N copies. At this rate, how many copies per second does it make? So before we get to worrying about the seconds, let's just worry about the copies per minute. So if I was going to write this copies per minute, you put copies on top, you put minutes on the bottom. N represents copies, T represents minute. So this is copies per minute. So let's just pretend I already knew the actual number. Let's say it was 1,000 copies per minute. And you wanted to know, well, how many is that in a second? Well, there's 60 seconds in a minute. So we would have to divide this number by 60, cut it up into 60 pieces. So that's what we're going to do. We're going to take n over t, and we're going to divide it by 60. Well, how do we do that? We're going to turn that to multiplication and flip it. So this is really 60 over 1. So it becomes 1 over 60. And you're going to multiply straight across. You're going to get n on the top. And you're going to get 60t. We always put the number in front as the coefficient. So it's n over 60t, which you can find right there is letter A. 17. The Talk-A-Lot cell phone company sells pay-as-you-go phones with 700 minutes for $70. What is the rate per minute? Cost per minute. So cost per minutes. So we're doing 70 divided by 700. And we get this. Now we're talking about money here. So cost per minute. So 0.1, that's 10 cents. There's your 0.1, 10 cents per minute. That's letter A. Letter B. If this is how much it costs for 1 minute, what's the rate per hour? So we're going to take that 10 cents and we're going to times it by 60. So that's $6 per hour. And then part C. She buys a phone and talks for a certain number of minutes. So let's pretend we knew how many minutes it was. Let's say it was 5 minutes. We already know it's 10 cents per minute. So those 5 minutes you would multiply times 10 cents. And the value of the phone, okay, how much money is left on the phone after you've talked for a certain number of minutes? It's going down, right? You paid $70 for 700 minutes. So after you use minutes, the number of dollars that are actually left on the phone, like if you're going to get a refund for the minutes you have left, how much is worth? It's less and less and less until it's worth $0. So it's coming off of the 70. It's 70 minus, and then it's 10 cents per minute that's coming off. So that's going to look like 0.10 M. All right, let's start a new page here for the review. So going down to 18. So for me, as I'm doing these, the very first thing I check is let's make sure that this is multiplication if I'm going to start canceling, because if it's division, I can't just start canceling. So it is multiplication, so we can go ahead and start canceling some things. So I've got an x on the top, and I've got an x squared, so 2x's on the bottom. So this 1x is going to cancel one of these. That means I still have an x on the bottom. I have a y and a y up top. That's really y squared. There's two of them. And I have a y squared on the bottom. So the y's are going to cancel out completely. Two y's cancel two y's, or y squared. So there's no y's. So all we have to do now is simplify some of these numbers. Now we have a negative over a negative, and there's no other negatives. So those are going to cancel out. This is actually a positive. And 6 over 3, I can divide those by 3, and I'm going to get 2. And I'm going to get 1. And 5 and 4, or 2 and 5, that nothing happens there. So when I multiply across, I'm going to get an 8 on the top, and I'm going to get a 5 on the bottom. And that is fully simplified. Now, we've talked about in past chapters, if you wanted to just multiply and you got the 24 and the 15, okay, and then simplify later, that's perfectly fine. So you use whatever strategy works best for you. So 19, like I was just referring to about a minute ago, is division, so we need to be careful. You cannot start canceling anything until you've changed it to multiplication. So the first one stays the same. Divided by is the same as multiply by the reciprocal, so 4b is going to come up top. A goes to the bottom. Now you're allowed to start canceling. So these a's are going to cancel. The b's do not cancel now. So you may have wanted to cancel these b's here, but you can see that they do not cancel. They're both on top. So that's going to give you a b squared up top. So I'm going to cross them out just to show that I'm done with them. And then I just have 4 and 21, and nothing goes into 4 and 21. So they are not going to simplify. There's your final answer. All right, 20 has an A and a B, and if you look at the two of them, it's the same thing, but one's addition, one's multiplication. So again, the canceling only works with multiplication, and for addition, that's something totally different, completely different. So let's start with letter A. So because it's multiplication, I can go ahead and cancel, but if you look, nothing here is going to cancel. And so we're just going to multiply straight across. It's a negative 8 times a positive 8, so that's a negative 64. N times n is n squared, and 3 times 3 is 9, and nothing here simplifies. That's done. Part B now, same two numbers, but addition. The whole reason for this is they want you to see that multiplication and division are going to give you two different things, and you need to be careful. So when you're adding, you have a common denominator. Your answer just keeps that denominator. Negative 8n plus positive 8n is 0. And so your final answer here, you got to choose. Is it 0 or is it undefined? So you can't always say it's one or the other. If the numerator is 0, then the answer is 0. If we had a 0 down here, we would say undefined. Okay, we skipped 21. We're going to 22. So I have 9 divided by 4/5. Kind of hard to see which is the big dividing line, which one's the small one. So that's 9 divided by 4/5. So that's the same as 9 times the reciprocal, 5/4. So really this is like 9/1. So we're going to multiply straight across. There's nothing here I can cancel. And that's going to be 45/4. And you can leave it just like that. It does come out to a nice decimal of 11.25 if you wanted to go that far. 23. Okay, for this one, it's division. So first thing I need to do is change it to multiplication. So I leave the first one alone. Negative 6/7 divided by 6/5 is the same as negative 6/7 times 5/6. You flip the second one, and now my 6's are going to cancel. So all I'm left with is 5/7. That negative does need to stay, though. Oh, and I missed a negative here as I glance back to the actual problem. So you can put the negative down when you flip it down here if you want to. And so if you did it that way, you would end up with a negative on the top and a negative on the bottom, which would obviously cancel. Or you can just look at it as a negative times a negative, and that's going to be a positive as well. So either way, your final answer needs to be positive 5/7. All right, division again. First thing we need to do is rewrite it as multiplication. Can't practice that enough to make sure we're doing that. So those b's are not going to cancel. Okay, they're just going to be multiplied together. So b squared on the bottom and a on the top. Dealing with the numbers, you could put the 6 and 4 and simplify later. I'm going to go ahead and simplify right now. You divide those both by 2, and so it's a 3 and a 2, and those are just going to stay right into our final answer. And 25. It's division. Now I'm going to flip, so I'm going to go ahead and put this over 1 so I have an easier flip and I don't get confused. So I'm going to leave the first one. I'm going to change it to multiplication. Dividing by this is the same as multiplying by the reciprocal. So the 1 goes up top. And now you'll see these d's are going to cancel themselves out. So now all I got to do is multiply straight across. So it's 2 on top, 15 on the bottom.